Hello, everyone. Thank you for joining us for today's session. Let's get better step by step LLMs in your business. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be looking for questions for our presenter to answer, and we'll be dropping links. The session is recorded. It will be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our speaker, Anish. Thank you so much for joining us today.
Hello, everyone. I'm Anish from Weights and Biases, and I'm really excited to talk to you about how to properly utilize Microsoft products to create really great AI applications and ensure that you're able to curate them effectively using MLOps platforms like Weights and Biases and our new tooling Weave. But let's get started. I think it's better to look at code rather than just talk about it. So for anyone who'd like to follow along, this is a QR code that you can pause at any point and take a snapshot of and direct yourself to this website. There's a couple of collabs and resources that link to how we utilize AI to create effective AI applications for your business. So we're going to talk about a few things. I do want to note that we will not be talking about the LM evaluation portion in this specific talk. If you guys are interested, I'd love to do a part 2, but just let me know in the chat or to the organizers themselves if you want to hear some more about the stuff we're talking about today. So for many of you, you're probably asking yourself, I like to ask these questions, and maybe you should ask yourself is, do you have any LM-powered tools deployed internally today? And if so, why and how are you creating them? Or if not, why not? Similarly, do you have any LM-powered products that you deployed externally to customers today? How are you ensuring that these are effectively being utilized by your customers? And how are you ensuring that you can actually have an effective pipeline to improve upon your AI products as you start to see this user increase from these different tools and features you're building? And also, one little fun one I like to ask is, would you actually bet aspects of yourself that you consider important on the accuracy, correctness, factualness of LM outputs today? So I'm not Morgan McGuire, but I'd love to talk about his portion, which is how we internally at Weights and Biases answer some of these questions for different features that we built internally at Weights and Biases. So one important feature is data cleaning. So LMs are actually very good at being able to take very very specific freeform user fields and actually decompose it into ways that we as humans can use it for different um, tabular based data, for instance. So in this case, this is all different fields which allow people to enter what region a certain customer exists in within our Salesforce database, for instance. However, because of the free-form nature of this, it's not standardized, where it makes it hard to do things such as critical analysis to understand which regions we should be actually sending things such as our AEs or salespeople to. And because of this, there's also things such as misspellings, which also make it hard to map where certain regions actually lie in. And even more so, when misspellings occur, things such as US, United States, USA, and etc. are actually all not combined together easily. So you could use probably standard techniques such as clustering or standard NLP techniques to go ahead and clean this data, but actually managing that pipeline and ensuring it's actually continuously used by your AEs or your sales folks is actually very difficult, we found, because of how much software bloat is naturally built in. As the freeform nature, as the data pipeline we build to clean these types of things isn't as robust as we'd like it to be. Enter LMs, though. With a simple LM call consisting of a very good prompt, which I'll talk about soon, you're able to actually take these free-form fields and misspellings and actually ensure that's returned in a specific, in a very usable form. So for instance, what we care about is actually ensuring that all of these fields resolve to a country, for instance, as that's the easiest level of aggregation we care about. So we want things such as Paris, ooh, sorry, Paris to standardize to France, any other languages, for instance, such as Deutschland, to actually resolve to Germany, and then things such as Freeland, where we actually have no idea where that might resolve to, we give it an unknown other category. And so we can see immediately the effectiveness of such a simple prompt with a very powerful applicable use case. So, very first step to ensuring LLMs can help you is make one really good prompt that's able to solve a very uh, consistent output you may want from LLM. So, in this case, the standardized output we care about is ensuring that all of our free-form user fields about location resolve to a country. And we saw immediate benefit from our analysis of understanding which customers we should be targeting internally at Weights and Biases. But I say one important point here, and that's what makes a good prompt. I kind of showed you one over here, and it's up to you guys if you'd like to pause and take a look at it. But there's actually a lot of heuristics that went into play here to make this actually a very usable prompt. Let's talk about perfecting prompting. So, showing up the link again for anyone who wants to go ahead and follow along to a collab I'm about to show. But there's going to be three portions to how we consider how to perfect a prompt. There's the anatomy of prompts, how to utilize this prompt anatomy, and then using these techniques together, or this composition for the anatomy of a prompt, to actually develop more advanced techniques. Those that actually allow things such as agentic use cases or agentic RAG use cases to be built. Something we'll focus on heavily, but we'll actually allude to as we start to decompose the prompt anatomy itself. So let's talk about the anatomy of prompts. So just a little bit of bookkeeping to make sure we all are on the same page about prompts. Prompts are how you communicate tasks to LLMs and get effective answers without the need to fine tune or train our own models. And so because of that, prompts involve instructions and contacts passed to a language model to achieve that certain task. So like in the case of the standardization of the country location of the location field within our table or Salesforce dashboard, that task is specifically country standardization based on pre-existing written free-form user locations. And so for us, we hear about this technique, this kind of paradigm called prompt engineering. And so that's a practice of developing and optimizing prompts so we can actually use LLMs effectively for the different applications that we're building. So for instance, some that I'll talk about later is customer support and marketing copy. Two things that I, as a growth machine learning engineer, really care about. Is I want to ensure that everything that we develop internally at Weights and Biases is marketed effectively to our core audiences and personas. And so in one case, that's ensuring that those using our proprietary tooling can actually get very pointed answers about niche aspects of our product that only either internal employees such as us know, or may live in a very bespoke part of our documentation or code base. And so LLMs are really effective like that, especially in the RAG-based use case. Similarly, for a marketing copy use case, we're able to fine tune our own version of GPT, for instance, to optimize copy to match the user personas we're selling to, be that end user and machine learning engineers for users of our MLOps platform, or to people new to the AI space themselves. So those who are doing prompt engineering or want to become AI engineers. The whole new persona that we now support with our Weave offering, which I'll show you soon. But today, let's build an app ourselves. Let's actually build something that we can use and walk away with at the end of this presentation. And so for me, what I use and love LLMs most for is an education-based use case. So the main concept of understanding text in a way that's very specific to how you understand information. So how can we take complex and proprietary web pages or data generally and ensure that anyone who walks in can write a description about themselves and get an output about this very complex topic in a way that is unique to that user who wants to learn from that complex data. So all of us are probably very familiar with our first basic prompt. We all logged on to ChatGPT out in March of 2023. March, I believe March of 2023. We all logged on chatgpt.com and we started toying with this. Um, so we may say something as simple as just saying prompt engineering is blank. And we let something like GPT-3 at that time, or 3.5 Turbo, depending on how when you join the game. But for them, this actually fills in the rest, where we can see that it says prompt engineering is a practice involving optimizing input prompts to AI models to get the best possible outcomes. So this is actually not the worst description. It actually does a pretty good job explaining that prompt engineering is about optimizing prompts to AI models, aka the inputs, as opposed to the model itself. And so the very first portion decomposition of the prompt anatomy we can say is that a prompt incorporates an instruction and then a response. And so we're actually jumping to some code right now. So to preface, because of the greatness of the information coming from Microsoft Build today, and for any of those here today at Microsoft Build, you can come and say hi to the Weights and Biases booth. We're going to use a lot of Azure products because they're some of the latest and greatest that exist currently within the AI space. And so we're going to use a mixture of Azure OpenAI, and we're also going to use, so we're going to deploy internally an Azure OpenAI GPT-4 Turbo model and a 3.5 Turbo model. And we're also going to deploy a Mistral model, which we won't use specifically in this notebook I'm showing, but Azure AI Studio allows us to easily grab open source models that are the latest and greatest in the world right now and deploy them in your own private deployment so that whenever you use your Azure OpenAI service or your Azure Mistral service, for instance, on the AI Studio, it's secure and tenanted to your specific team or environment. So send whatever proprietary prompts you'd like, if you'd like to, and ensure you just turn off the toggle that says "Don't use my data for training." And from there, you have a lot more security behind the scenes, leveraged by Microsoft to ensure that you can pass whatever you want to these services with the safety of knowing that lives within your own system itself. And then we at Weights and Biases also offer additional tooling to ensure you can actually take these outputs and usages from these models and actually build really strong pipelines to ensure that you build better LM applications, can evaluate them, and select the best models and prompts to push to production. So let's get back to building prompts, though. Enough of the spiel. So in the very part one of this workshop repo, that the QR code should have taken you to. We're in the part one prompting section. There's a bit of cheating occurring though, where I need to update this to actually incorporate some of the Azure stuff we're doing. But let's just use our magic hats for now and just follow along. So over here, we just set pretty much. We're going to use a package called LightLM and Weave. LightLM just allows us to easily swap between different LLM-based providers without having to change too much of the code needed underneath the scenes to actually interact with the LLM. And Weave is the new product by Weights and Biases to allow us to have a end-to-end way of evaluating and understanding how our LLM is used within the application that we're building. So once we set those up and set some environment variables, so in this case, because we're going to be using Azure OpenAI, we're going to set the API key, the API base, which essentially is the deployment endpoint that was noted after following the instructions of how to serve your own GPT-style model. And then the actual model we're going to run itself. So in this case, because we're going to be using the GPT-4 Turbo model deployment. And so in this specific situation, we're going to create a bot that's going to teach us prompt engineering. And so as a heads up, so actually, let's just start from the very beginning. So over here, we're going to create our connection to our Weave server on Weights and Biases. So upon clicking into this, you're going to see, for you guys, empty dashboard. For me, you're going to see a collection of these different interactions I had with my large language model. They're all saved and serialized in one location, and also very easy to actually go down and make comparative analysis about. So instead of just talking about it, let's show you. So within our main function, we have this kind of get completion function. What we'll do is actually interact with LM for us. So we have a system message, which we'll talk about later, the current state of the chat that we're at with the model, the specific model we want to interact with, and things such as max tokens and temperature. Another thing that I obfuscated from here is also top P, which I'll talk about. All this does is essentially say, hey, talk to my large language model and complete the rest of the conversation. So from a user perspective, oh, this is a weird error. Let me rerun some lines of code. So I'm going to ask our GPT-4 Turbo model, hosted on Azure OpenAI, to explain the latest prompting techniques and provide an example of each. So at this point, we're raw prompting our large language model without any other specificity to allow the model to simply spit out an answer based on its internal understanding of what prompting techniques are, and then going ahead and providing an example of each. And so as this runs in the background, I'll actually go talk about a few other topics, a few other tenets of the instruction prompt as we interact with a large language model. So temperature and top P were two specific parameters that I noted. Temperature and top P essentially control the creativity of the output of a large language model, where temperature and top P focus on two slightly different perspectives on that. But in general, you keep these values low if you're looking for exact answers. And so, for instance, in data extraction use cases, finding a nice balance between temperature and top P can ensure very accurate and consistent information retrieval, while keeping both these values really high allow for creative and diverse storytelling. And so the reason I emphasize creative and diverse different from each other is because that's kind of the difference between temperature and top P themselves, where temperature adjusts how adventurous the model is with its available word choices by reshaping the selection, the properties of how it selects the underlying next word in the sequence, by reshaping that probability landscape. So very high temperatures uh, create more varied and human-like responses, as it's selecting a lot of different words that, instead of choosing the same ones that would currently exist within its selection of words available to it. While top P, on the other hand, actually thresholds what specific words are available for the large language model to select. So instead of saying temperature allows it to essentially determine, of all the options, how it chooses to select, well, top P actually limits the options available. I personally say use temperature more so than top P, as top P can create really repetitive selection of words, where a super low value, for instance, may only allow it to have 5 words, for instance, to select only, which is a very bad, as most of us don't only use the same collection of words. Instead, we choose to select our large vocabulary words in very interesting and compelling ways. And in general, when creating a good prompt, you have to think of LLMs as just like another human that's new to a job. They don't have any context other than what you provide it to. So if a human can't sit down and respond to a prompt you pass an LLM can't do so in a good way either. Though some LLMs are really good at intuiting what we actually want behind the scenes. And there's actually paradigms that exist that allow our large language model to intuit automatically. So let's actually go back to our code now, because it should have finished. And you can see here that, sorry, this is a bit hard to read. So we're actually going to jump into our Weave dashboard right now. Let's close these ones out. So on this right-hand side here, you actually see the decomposition of our LLM app. So we can see here that our prompt LLM takes in a question and some additional quargs and spits out the raw answer. If we jump into get completion here, though, we can see that all of the different parameters available, so the system message itself, the list of messages, the model, the max tokens, and all of the actual choices returned by OpenAI, alongside things such as what I find useful, the finish reason, are all listed in here. So at the top level, this is what the end user may see. Just ask a question and get an answer. But for us as prompt engineers, or engineers, AI engineers building really complicated LLM applications, we actually want to see the full drill down. So Weave allows us to create these trace trees, which allow us to actually go ahead and understand the composition of internal interactions with the LLM that our core end user AI app is doing. But let's actually see how well this model did. So I'm actually going to see that, okay, we have explained the latest prompting techniques. I'm going to hide this and actually render this as markdown because it's a little nicer to read. And we can see it actually does a really good job. This was a bit surprising as I was testing this earlier, as GPT 3.5 Turbo, GPT 4 Turbo, and Claude Opus, um, all from the Anthropic and OpenAI folks directly, didn't actually have this in depth of an answer. It said actually something along the lines of, let's actually see if I can find one. So jumping into Weave back here. Uh, prompt LM. I do not actually have the knowledge about the latest prompting techniques. I'm an AI assistant created by Anthropic in this specific situation, and I do not keep up with the latest developments in AI prompting methods. We actually see that the OpenAI Azure version of GPT was actually able to effectively give us a response that has a lot of the techniques that I'm going to show you later. So usually at this point, I'd say if it gave an answer like the Anthropic one did, I'd say something along the lines of LMs are useless and we can't actually use them, right? In this case, actually, our LMs are actually pretty good from the get-go. But the problem here is it has a lot of extraneous text to them. It says things like, as of my last update in April 2023, and this form, although nice, is not exactly the form that I may understand these different techniques that it's explaining. So you actually may want to do something such as directly providing the context of what I want to have learned to the LLM itself. So in this case, I have here explain the latest prompt techniques and provide an example of each. And I also provide a sentence which may explain the different available techniques that exist within the world of prompt engineering. So when you pass this whole document into a large language model, that's called in context learning. If you actually use things such as vector databases and you dynamically retrieve the best context and provide it to a large language model, that's called RAG. At the end of the day, it's all about just shoving the right context given a query into a large language model so it still solves that task that we want to have solved. And so in this case, let's go ahead and do that. So if I scroll back up here, I provided two fantastic web pages rendered as Markdown from Aman Chada and Lillian Wang, both of which provided prompt engineering techniques in a very, very detailed and rich form. Where I would say Aman Chada's is actually currently being updated, I believe. So it's a significantly longer list than the Lillian Wang's prompt engineering webpage, which I think was last updated around uh, fall or end of last year, 2023. And so I say this to say that we're not going to use Aman Chada's webpage in this specific example. We're going to use Lillian Wang's. Lillian Wang's, because of the shorter context length, is a little bit easier to curate and ask questions to for a large language model without having to have extreme prompt engineering techniques. Due to the length and granularity of the techniques mentioned in Aman Chada's, it would actually require a lot more strict prompt engineering. So for those of you who actually find value in this application we're building right now, I'd say play around with Aman Chada's. Swip out the prompt guide that we currently have as Lillian's prompt guide, and instead swap in Aman's and try to make your own better bot that actually answers way more advanced techniques that only may have came out a few months ago, or not even a few months ago, because that's ages in the LM world. A few weeks ago is what I mean to say. So how do we actually pass this context into our large language model? Surprisingly, really easy. In this case, you can actually just shove in the context here. So let's actually go run these few cells. Let's actually go ahead and load that specific prompt guide and then pass it into our large language model. And so as this runs behind the scenes, because of the nicer, larger context length that exists within large language models, we can actually shove whole documents into it and directly ask it the question we want, given the above document. So in here, some things I could have done to improve this is actually say, given the above document, explain the latest prompt techniques, etc., etc. But for now, we're actually finding a lot of success by simply pre-pending our question with the context directly. And so as that renders right now, we're going to actually move on and talk about a next piece that's going to be useful that I kind of alluded to just now is system prompt. So while it might be nice to simply pass in a context and the question itself and call it a day, it actually gives an output that is up to the large language model to decide things such as tone, style, and d- um, how it actually manifests the response so that it could be either very advanced or very simple. And so I would say that being able to determine what makes the most sense for the task you're trying to solve, understand the tone, style, and complexity of the output is very useful to not only understand, but to directly note in something like a system prompt. Where a system prompt is essentially now the new form of pre-pending every question we as a user ask to the prompt to a large language model so that globally the large language model knows that it should always do this for every message coming in from user. So for every message, it is prepended now with simplify prompt engineering with clear jargon-free examples and metaphors, ensuring clarity and practical applicability for beginners. And then the same stuff we did before. So the instruction and the context. We're actually kind of messed up here where I would have actually swapped the two now that I say it out loud. So let's actually look at the answer of the response when it wasn't given a system message. A bit hard to read here, so let's go look at it in our Weave dashboard. Full screen. And so we can actually see, sorry if I were to show this again, we actually see the question itself. So you can see that full markdown we had here alongside that question we asked. A bit hard to read, but that is now the new essence of this question itself. But hiding this. Now let's go ahead and see the output of this model. And so it's kind of nice. So I lost some of the jargon already in the beginning, where it said like as of April 2023, I as a large language model know this information. Instead, it actually directly goes in to the article itself and grabs the technique, an example of that technique for each of the different techniques that it found important to talk about. So in this case, I talk about chain of thought, self-consistency, instruction, few shot, zero shot, and then automatic prompt design. I wouldn't necessarily say that these are the ones I would select in this order, for instance, but it did get better at being able to select a very specific subset that was mentioned in the context we provided earlier. But I don't really like the output of this. This example isn't as clear to me because there's no real decomposition of the example itself. The technique here also isn't very easy to read at a glance. I want to make sure I have build a guide essentially that at least for me, a very busy person, can go and just look at a glance, say, oh, this is what chain of thought is. And so what we can do is actually go ahead and define those rules for us. And so here are some rules I have internally when designing good system prompts. So I define a clear objective to large language model, specify a role to the model. So, for instance, I may say something along the lines of you are a teacher or you're an advanced university professor teaching a high school class as part of a webinar, for instance. So, advanced underlying knowledge, but teaching to a what would be considered a audience that may not already have that like collegiate level understanding of certain techniques or paradigms. Set the tone and style. So in this case, you can say something along the lines of use that jargon-free, metaphor-free examples. Provide contextual details is an interesting one because there's two places you can directly pass context. So for instance, you can shove the context directly in alongside the question like we just did now, or you can pass the system prompt if the context that you want is a global context. So you want some information to be provided to every single input by a user as it answers questions. So in this case, the prompt guide actually is not a bad decision to put in the system message here. But I won't do so in this example. I find it that we're not building a fully fledged example where we have like a multi-turn conversation. I would say this provide contextual details really matters in that multi-turn conversational setting. And then lastly, use structured formats. I'm going to omit that for now, as that's going to be another portion we talk about soon. So over here, let's actually go through and follow the rules we just set. So we actually simplify prompt engineering concepts for easy understanding. We want to be friendly and educational, suitable for beginners. We wanted to assume basic AI knowledge and avoid deep technical jargon. So assume that about that us as the audience. Use metaphors and simple examples to explain concepts while maintaining conciseness and applicability. Ensure clarity and relevance in response with practical examples, and help users grasp prompt engineering basics, enhancing their AI interaction experience. One thing I definitely say is use large language models to help you construct these. There's actually a whole paradigm called meta prompting, where we actually can use tools such as like the folks at Anthropic to go ahead and help you develop really good prompts, given examples and tasks. But I'm going to get a bit ahead of myself. We'll talk about that a bit later. So now, given the system message and the question itself, let's go ahead and run this. Let's see how the answer actually changes. And so while this also runs in the background, we'll talk about our next portion, which is once we are satisfied with our system prompt, the questions we're asking, the context we're providing alongside our questions, we actually go ahead and start to build an LM app. So earlier, I'm going ahead and actually hard coding this question essentially and passing it into our prompt LLM call. We can actually use things such as fast strings or Ginger templates to go ahead and actually templatize this now effective prompt we've curated to ensure that we can dynamically go ahead and pass in questions from users. Because luckily of F strings and Ginger templates, this is very straightforward to do. And the reason we want to do this is we want to ensure reusability across different contexts without rewriting too much of our code. So, for instance, as we're building out LM app as an AI engineer, we may want to change this question over here. So in code, I'd have to actually go in and change this manually, git commit and push it into our application. That seems a bit archaic given some of the interesting techniques we can actually provide into here instead. Another thing is we actually now compose our prompt as a modular uh, as a modular tool itself. So, for instance, a prompt can now be split up into different components. So, in this case, I may have a very basic prompt where I only ask a question. But let's say you may want to pass in a question, but you also want a user to pass in their own user context. Maybe you want to pass in an example. All of these can be different inputs that are dynamically imputed into the curated prompt that we're going for right now. And so, because of this dynamic nature at runtime, it allows us to have this customized interaction alongside the modularization. So, as we start to develop um, more and more reusable templates, we can add or remove variables as we start to understand how users use our application and what's actually important for our users as they input this information to our large language model application. All of which can be analyzed from a user pattern perspective from Weave itself. As we actually see that inputs from users and those outputs, we can start to make key decisions about what actually are important variables into my prompt template. And next, we have kind of the standard software stuff, which is you actually have clear and maintainable prompts, which are now in essence almost like a way of because of how it's interacting with large language models. Similar to code, it's something that we want to maintain as clear and maintainable as we use these LLMs as a big facet of our reasoning engine in a way within our LLM, our AI features. And next, we also have enhanced control, which go hand in hand with that modularity and dynamic portions I mentioned earlier. And so now that we know about user inputs, let's actually go back to that system message and see how well our GPT model did. So we can see here, very similar to before, we have all that full question. We also have the system message here. We can see that has that system message we wrote, which has the pretty much a call to the large language model to keep this simple and straightforward. So going back to here, let's hide this. Let's look this in Markdown. So this is a bit easier to read. And so you can see here, the reason I say it's a bit easier to read is that now the writing, instead of being something along the lines of it involves a sequence of intermediate reasoning steps or rationales that lead to the final answer, we get something a little bit more human understandable. So imagine trying to solve a complex math problem or complex problem, like if you're a math puzzle. Instead of jumping straight to the answer, you break it down into smaller, more manageable steps. That's exactly what chain of thought prompting does for LLMs. And then you can see here that the example says, if you have 5 apples and give 2 away, how many do you have left? Let's think step by step. You start with 5, you give away 2, so you subtract 2 from 5, therefore you have 3. And so for each of these techniques now, we actually have kind of like this multi-step example breakdown, not also in a weird markdown block, but also each of these techniques are all using really simple metaphors. So none of that jargon that we saw earlier when we didn't provide the system message. I'm very satisfied with how this is turning out to be. So when we go ahead and actually templatize our large language model, it's very easy. So using those same curly braces in the slides I showed earlier, what you can do is actually provide the variables that you may want to impute. So in this case, context is the context from the prompt guide from Lillian Wang. And the question itself is the question that we want solved. So explain those different techniques. So for here, we have now this function called format prompt, which will take this prompt template and shove in whatever variables you want. So in this case, that context and question. And so now our application is as straightforward as using that same prompt LLM call I had earlier, but instead, the prompt is something that's formatted automatically for us. And what's nice is that because we're using Quarks very intelligently or like very interestingly, we can still pass all the other parameters we may want. So in this case, we pass the prompt template, the context and question, which gets shoved into the prompt template, and then the system message itself. So after running each of these pieces, we'll actually see the immediate benefit of doing this from an experimentation basis in our Weave dashboard soon. And as this runs behind the scenes, let's also talk about another portion of actually standardizing the usage of our large language model. So user inputs allow end users to go ahead and be able to dynamically allow important pieces of information to be ingested by a large language model. But then the large language model, although providing nicer responses here, is actually not providing a response in a way that may be useful for application developers to utilize within the extended software system that they're building. So over here, for instance, if I were to view this as JSON, this not this piece, I apologize. For instance, if I view this as JSON, it's going to say value is not valid JSON. And also, if I asked you to go ahead and take all this information and say this was the output of a large language model, go ahead and extract it consistently to be used in the rest of our APIs, for instance, where you may want to have this processed in a data pipeline in a very consistent manner, this would break your pipeline. You know, the large language model is non-deterministic and also is spitting out text, which would require you to either have a very strong parsing algorithm to extract out that piece of information you want, or you can tell the large language model, hey, spit out an answer in a form that's actually usable by me. And so luckily, we're at a point where due to all the alignment work and different fine-tuning slash further pre-training techniques done by the community and the great researchers of the world, this is actually very easy to do now. So like in the case of GPT, for instance, it's very actually straightforward. So this example says markdown, but we can also we can change things up in our head. We actually tell, for instance, GPT to say, you must respond within JSON, where your keys are X, Y, and Z. So in this case, I may something say, you must respond within JSON within the key of answer. And so here, what we can see here now is that, let's keep it markdown actually, just for simplicity's sake. You can see that now this answer, which it was told it must respond within markdown tags, actually responded within those answer markdown tags. So if you were to use an XML parser, it's very easy to say, extract all the data from my XML tree within the answer tags. The side note on this structured outputs is that GPT prefers JSON responses and also has a very specific flag for JSON return. And then open source software tends to have their own weird way. Most of them actually now resolving to JSON also. You actually have to say the phrase respond with JSON, or else the large language model just won't know as well. And there's actually, even though this JSON form is nice, errors still can occur. Once in a while, the LM may not actually use the proper key, may say answers as opposed to answer, where if it has like especially like a multi-part answer, for instance, or also I just mess up in general. So tools such as Instructor, which I highly recommend, make this a bit easier by actually utilizing more of that function calling aspect of large language models alongside by pydantic data classes. I'll show a little bit of that later when we go through one more business use case of large language models. So let's go ahead and actually run this portion. So over here, this is a very long-winded way of saying, hey, you must respond in JSON format and respond within a structured JSON object where I have a couple keys. Condensed answer is a full answer based on all the different explanations that occur under explanation, where each explanation also provides an example, where this is an example of that JSON itself. So the annoying part about this is that you do kind of have to provide things such as what you want the structure to look like, as opposed to just using it in text. I've noted. So over here, we actually append this format descriptor in our system message. So every message interact with LLM knows to format it within this text description, while the prompt itself was actually going to be provided this specific output format of an example of the best case situation with this JSON object. So we can run this. So in this case, because we have now that dynamic user input and we have a very specific form of how you want the output, I'm going to change the question up. So in this case, I'm going to ask it to explain the difference between zero shot, few shot, and chain of thought prompting, but providing a clear explanation and practical example for each technique within that structured format. Because we actually are using a GPT model, I will say that the response format type will be JSON object. And so as this runs behind the scenes, let's go talk about some advanced techniques we'll talk about soon once we have this output format. So using this prompt anatomy, we'll talk about the three techniques I just asked a question about: zero shot, few shot, and chain of thought. Because the slide deck will be shared earlier, and this is a block of text I realize I just shoved in front of your face, let's just read the parts in blue. Zero shot prompting is what we've been kind of doing right now, which is that without using additional examples and relying solely on the general knowledge of the large language model, describe the specific or like answer the specific question. Or in this case, we ask about those different techniques. Few shot prompting, it actually is about providing exemplars to the model. So to keep it simple, you actually provide examples of what you consider an ideal answer to the question or task you're trying to solve. What's nice about this is that it doesn't even actually have to relate to the content of the task itself. If it's something like where you want the structured output, for instance, to have a certain tone or style, or you want it to actually match the descriptions you wrote in the system message, by providing an example which has all those pieces, where maybe has those jargon-free examples or explains examples in a concise and simple manner, this is where you actually provide those examples here. So in the case down here, where with few shot, I simply say without using any specific examples, and few shot, I actually provide saying, here is the different prompt techniques: translation, sentiment, classification, factual question, where these are different techniques about guiding language models for tasks, as opposed to actually explaining different prompt engineering techniques. It still learns the language of these ideal answers and answers the specific question I asked still. Oh no, this is going to break probably because I didn't turn this on. It's fine. So I'm going things a bit out of order because things were run a little bit after the fact. But jumping back to the output indicator portion, which is mimicking a zero shot problem, If I actually break down and look at this LLM app from the Weave dashboard, you can see here, here's my prompt template now appended with that JSON format I mentioned. Um, the context is now separated from the question itself, so we can actually analyze the context, uh, isolated from the question. We can see the question here, and we can also see that the system message and the response type. So this allows us to do that clear experimentation as we've been doing, building up to this really good prompt answer. So over here now, we can see that, yay, this actually responded in JSON. So actually go ahead and press the JSON button here. We can see that this is something that I could actually use in my applications. So now I can actually parse this JSON dictionary or JSON object and go ahead and use the content answer or the different levels of explanation we have here. Where in this case, we actually look at it, each of these explanations relate to each of the three techniques I asked to be compared. So zero shot, few shot, and chain of thought, each of which provide an example where this condensed answer here actually provides the explanation of differences, where zero shot involves asking the model to perform a task with any prior examples. Few shot provides the model with a few examples to learn before performing the task, and chain of thought guides the model to solve complex problems by breaking them down to simple reasoning steps. Easy to understand. So this is run. So now if I were to go into here, let's say, so that's example, for instance, a few shot. If you actually want to go in and see this zero shot earlier, this is this few shot example. Also, you can see here this application decomposition still. So you can see how the prompt actually formatted into the pure question we passed to the model itself. And we also can see what we prompted the large language model with and the answer. So over here, you can see that all of these pieces come together and are decomposed internally and used in different aspects of your LLM application. So over here, if I were to render this as JSON, one problem we can see here immediately is that this actually did this in a JSON markdown block. So ideally, when parsing this, there is going to be some issues. And so you can see here automatically where some of the issues with not being using the structured output without using a third-party package like Instructor or having some sort of validator after the fact can come into play and cause issues. Over here also, you can see that I actually added additional keys. So the example, full screen. We actually see here that the example itself learned to add in a prompt and model response key underneath example, which may be unintended or intended behavior, depending on how you compose your LLM application. And lastly, we also have chain of thought prompting, one I find extremely effective. I'm not going to use JSON response for this one, where chain of thought allows us to actually understand the internal reasoning process of this large language model. I find this extremely useful as it allows us to actually ask the model what it thought about, especially in the case of using this for experimentation reasoning. You may actually want to add in this portion to understand how a large language model interacts with a prompt you gave it. But in production, you actually may want to remove this. Or as I'll show you soon, you actually may want to be clever and store the chain of thought as something internally, as like another aspect of the output of large language model, but only parse out and remove the end user portions. So like in the world of a JSON response object, I may have actually wanted to ask it to add a field called chain of thought, and I don't parse that and use that downstream in the rest of my software stack. But if I were actually jump into the chain of thought here, full screen, mark down. So you can see here now in the very beginning, it's actually going to provide its thought process. So to understand the difference between zero shot, few shot, chain of thought processing techniques, let's break down each concept into simpler terms and provide practical examples for clarity. Not the best chain of thought, I would say, but it goes ahead and does what it says entirely. So it did explain the breakdown of thought process and then went ahead and then answer the question. Well, at the very end, it does give a structured format. It's or its own understanding of what the structured format comparison would look like. So you can see here that there's a good combination of using these lower level techniques like zero shot, few shot, and chain of thought alongside really good prompts to get a lot of power with experimenting with your prompts. Hopefully leveraging Weave, which is a very strong toolkit for running these types of experiments. And what I'll do really quickly, and I'll hand wave through it, this deck will be provided to you all, is that all of these combination of techniques can be used together to create really advanced techniques. So for instance, if you want to do something like reasoning enhancement, like in the case of agentic use cases, where agents have access to tools such as the internet, databases, or calculators, you can use techniques such as a React, which is a prompting paradigm, which allows a large language model to continuously interact with itself and understanding of all the information it's grabbing as it runs through the different tools available. So it may look up some information on the internet and remember it, and they then may use that information to look up more information on the internet, remember it, do some calculations based on all the information that's remembering, and then once it reaches a point where it internally knows that it has the answer, it stops. So this actually is a combination of those techniques we mentioned earlier, where, like, for instance, chain of thought is really clearly defined here, where it has a thought action observation space. And so I call that reasoning enhancement, as it allows us to actually allow the large language model to dynamically increase the reasoning capabilities of itself by incorporating additional steps, tools, or consistency checks. So it can fact check itself or understand whether or not it needs more information and then grab that additional information. Next, we have the structural prompting techniques, where it's all about taking maybe a complex problem and decomposing it into more manageable steps. So programming thoughts directly will take a question, like in this case, one that's a little more mathematical, and actually break it down into a collection of variables and function calls, so okay, mathematical function calls, and can go ahead and run this in a Python runtime to actually get an answer. This is really useful for, like I mentioned, scientific and mathematical use cases, as a lot of times, a large language model doesn't actually run calculation itself. It's good. It's good at being able to know how to use a calculator. It's bad at doing mental math, for instance. So structural prompting is really helpful for that decomposition of those complex or mathematical problems. And all those tend to start with chain ofs, program ofs, graph ofs, tree ofs. So if you see any of those prefixes, know it's probably some sort of structural prompt technique about decomposition of higher order complex problems. Another interesting one is optimization techniques. So automatic prompt engineer automates the process of generating good prompts. And so that's kind of this concept of how can we optimize the prompt that's being utilized globally by our large language model. This is especially useful in not necessarily in LLM use cases, but text to other media use cases. So text to music, text to audio, text to video, text to image. This is really useful in those situations, especially as the prompts that are utilized in those tools are a lot less free form or natural language in nature, and definitely revolve around really powerful tags in a way. And so in this case, for instance, we may have something like John has 5 apples, he eats 2 and buys 3 more. How many apples does John have? This one actually decomposes a prompt or creates a prompt that is more so about how to solve when John determining how many apples does John have. So in general, if we change the initial number of apples and determine and yeah, so determine so so in this situation, this prompt will always be useful when John has some degree of apples, he eats some apples, and then buys some more apples. So this generic prompt is now a John apple solver in a way, and so that's how this prompt was optimized behind the scenes. So, for instance, the task in this case is optimized for that understanding of how many apple John has given a sequence of steps that consistently occur to John on maybe a daily basis or a weekly basis. And lastly, is this lastly? Yes. And lastly, we also have interaction techniques. These ones I find really cool. This is where concepts such as query upscaling from LLMs occur. So this is about the idea of improving a model's understanding of the user's intent by rephrasing a question. So as opposed to optimizing a prompt, we're actually optimizing the question in a way. So for instance, a question might be, what is the difference between a meteor and an asteroid? In this case, what a rephrase question that's a little bit more granular in what this actual difference may look like is, what are the key characteristics that distinguish a meteor from an asteroid, consider their composition, location, and visibility from Earth. So it knew behind the scenes, the large language model, that there were differences across these three portions of composition, location, and visibility. So you need to explicitly add that as part of the question, and also change what is the difference to saying what are the key characteristics that distinguish both from each other. So that's an example of how rephrase and respond is really useful. And this, I find this actually very useful, for instance, in RAG-based use cases, where, for instance, you may have a question coming in from a user that it actually may not be really good for retrieving a good document, for instance. So you might want to do is actually rephrase a question coming in from a user so that it actually is much more useful for retrieval within your RAG-based pipeline, for instance. Well, with all said and done, what we learned here is that effective prompts have consistent in formats that can be experimented on. And that because this format exists, we are now able to have these advanced prompt techniques, which have been broken down into reasoning enhancement, which is similar to RAG, where we dynamically select new context and impute it into a large language model. It can be structural, like an advanced version of chain of thought. It can be about optimization, where we can let all LLMs optimize a prompt, or interaction, where we let LLMs understand and optimize a question. And so, where an example of this from a business perspective, which I'd recommend doing this within your own business, similar to the data extraction and data cleaning use case from earlier, what we can actually do is do something like understanding use cases from call transcripts. So by adding in a really good prompt about decomposing things such as speaker diarization, we're going to try to understand asking our large language model to only grab information from our customer and then understand what their use case is such that it's relevant to weights and biases. This is kind of the workflow that we have. So I do apologize. So at this point, you may want to pause and like zoom in and look at stuff. But there's a lot of different internal gateways or I guess state processes that occur to actually determine at what point a use case that's extracted is one that's going to be usable for us internally at weights and biases. So we use a technique called chain of density, which goes ahead and actually iteratively runs through a very large context-filled document and keeps on increasing almost like a summary of this specific transcript itself so that we actually accumulate our understanding of the use case as the conversation goes on, as someone within the sales process might do as they're talking to that customer. So you might say, okay, initially talking about large language models. Oh, later on they mentioned RAG-based use cases for sales processes. Okay, cool. So we know that they're actually working also in the finance pillar. And so as that conversation goes on, we understand that they're LLM generative AI customer. We know that they're doing RAG use case and within finance. And so we can actually combine all this information together, which is usually way more verbose, as we can see in this kind of a little snippet of transcript here. Instead, we can see that this can be used to accumulate a very strong use case response from our large language model. So for instance, we can say that in this specific call from our Salesforce transcripts, we actually now grab and say, oh, they want to use LLMs for customer service and contact centers, fine-tune language models for similarity scoring, and using larger LLMs to evaluate and fine-tune smaller LLMs. So this is what chain of density and good prompts can do, especially when you templatize your prompt in a way that you can run these very iterative processes. So you can imagine in here, we're actually running our large language model app over and over again, but maybe switching out things such as the context, question, and other components of our LLM app. And so let's also go look and understand how we can build a really strong use case for LM applications and not just talk about the system prompts that are used in these really strong LM applications. So we're going to actually do more data analysis work. I find that LMs are very useful for those use case extraction use cases. Very funny way to say that. Data cleaning use cases. And now we'll talk about actually naming and understanding things such as clusters, for instance, which is a very powerful tool in our data scientist toolkit. Similar to before, some different use cases that we can use for large language model are things such as prospecting, product reviews, and incidences. And so the data we're going to actually use in our specific case, where we want to do something where we actually want to cluster and understand the landscape of large language models and understand what different buckets exist, we're going to use the 2024 MAD landscapes, which stands for ML, AI, and data landscape. I recommend taking a look at this. It's actually a very cool chart where if we zoom in, so this is where you can pause and zoom in if you'd like, or go to that link at the below, we can actually see that there are a lot of buckets that exist in this specific landscape. There's this giant green one, which stands for infrastructure. But internally, we have things such as data warehouses or, sorry, it's a bit hard to read. Let me see if I can zoom in. So data visualization. Wow, this is very blurry. Or in this specific situation where we have machine and artificial intelligence, maybe this is a little bit easier. We have tools such as NLP, where we see things such as Hugging Face or AWS, as we'd imagine, or AI hardware. We see NVIDIA and AMD also. AMD. Let's see. Yeah, I think that's good enough for now. Some word here is weights and biases, but there's just so many logos, it's hard to find. So what we might want to do is that we might want to create something like this ourselves. This is a very useful useful tool for people trying to, like, for instance, VCs who want to understand the landscape of the ML AI world, but also for us to understand maybe what are some good customers that we may want to reach out to. If they fall within a certain cluster, they may be more likely to purchase our product as they're at a certain stage within their company understanding, for instance. Understanding with ML and AI. And so how we might want to do this back in the day is that we want to embed documents using something like BERT or BERT topic. Then we may want to use something like UMAP to reduce the dimensionality of the different embeddings that are created from BERT topic. And then we may want to go ahead and take those smaller reduced embedded data points or embeddings and then cluster them together using HDB scan. So we can have this semantically similar clusters. And then we can actually use tools such as TF-IDF or MMR to actually create topic representations from those clusters. But using LLMs, we can actually take this a step further. So after using the BERT topic to embedding to UMAP to HDB scan workflow, we'd actually go ahead and, given the samples from each of these clusters where we have access to information such as the company description or some other metadata about the company itself in text form, we ask the LM to sample from each of these clusters and then name it based on the different text data that was available for each of the data points that were all clustered together after running HDB scan on the BERT topic separated data points. Then we also use LM to eliminate duplicates. And then based on that, we can actually condense and rename the clusters that exist. So we now have this iterative flow where we name a cluster, use LM to eliminate duplicates, assign new clusters to each text, and keep doing that over and over again. And so because of that, we need to ensure that in this case, structured outputs is essential, especially as we're using LLMs as a component in an overarching data engineering or data analysis workflow or data science workflow, whatever name you want to give this. And so because of that, manually writing your own JSON example and putting it into the prompt itself is not really a great way to run experimentation. And two, it's actually not always the most consistent, as we saw that one of the responses from our large language model in the previous notebook returned a JSON markdown block, not even JSON itself. So this is where we actually use a tool called Instructor. Instructor actually allows us to specify pydantic data classes so that we can actually force the large language model to have a very consistent format very consistent format, and also has built-in capabilities such as retrying if it learns that post validation that an output wasn't proper. So for instance, you may want to add a validator that certain keys exist in the output of JSON. And if that key doesn't exist, rerun the large language model. That's what Instructor allows us to do. So this is an example of Instructor, for instance. So our class here is run user info, where name and age are the two fields we want for user info. After patching OpenAI with instructor's capabilities, we can pass a response model called user info. So for instance, if I pass in John Doe is 30 years old, instructor will extract out the name as John Doe. So user info.name is now John Doe, and user info.age is the age that was passed in. So you can see here immediately how this is really useful for downstream application usage, as this data class now has access to all internal attributes that we find useful and were explicitly mentioned here. Note that the large language model will also ensure that's within a string form and an integer form, as we typed those explicitly in the pydantic data class we just made. Oh, it's called pydantic base model. That's fine too. And so this is also LLM agnostic, which is not that important because we're going to use Azure OpenAI, the greatest and most secure form to use OpenAI. And so what's cool here, so I do apologize for the fact that it's all commented out. You can actually go ahead and nest these components together. And this is where you can see a lot of power come in. So for instance, a address may be something that we want as part of the person from earlier. So for instance, we may have a person that has a name and an age, but we may want to actually also grab their address. But address has its own fields. It has its address itself, so the full street address, but also has city and state. What's nice is that we can actually go ahead and pass additional attributes into our nested classes, for instance. So in this case, we can have our person. So I do apologize, the name changed from user to person, but they're effectively the same. The person, so the person address is now an instance of the person, but has that attribute of address. So if I were to actually look at the JSON model scheme that occurs for this specific person address, we can see that now has address with properties of address, address, city, and state, but also has the properties of that user from earlier. So it has name, age, and this address now backlinks to this address attribute based on this other data class we mentioned. And so because of that, we're able to create really strong nested structures, all without needing to write it explicitly in JSON ourselves, and also doing away in that it's actually very standard. Like it's very normal to go ahead and explicitly type and create what models exist in your software application. And so having that also be a part of how you write that into your large language model is very composable. So now you can go ahead and actually modularly create very strong data classes that you pass into your large language model. And the only thing you need to change as a developer is just change maybe an internal attribute, which won't necessarily change how it interacts with your large language model at all. All it changes behind the scenes it knows that, oh, I may need to add in address. And it goes ahead and adds in that address field, all of which can now be extracted by that response itself. So response.address is now an available field. And at no point, nothing breaks, for instance. All you're doing is you're adding on more additional attributes and features as you develop your LM app, which I find extremely awesome. And so one thing that's also really nice is that because Pydantic is typed, we utilize the typing very strictly too in instructor. So not only can you say things such as age, name, you also say things such as provide a literal answer where the options are either Gryffindor, Hufflepuff, Ravenclaw, or Slytherin for a Harry Potter character creator, for instance. And so this is really nice because now you're forcing the large language model to select one of 4 criteria. Similarly, you can also use things such as list or enums to go ahead and say, hey, provide me a list of property, for instance, where in this case, a property is simply a key value pair, a very simple form of a individual JSON list object. But because we have also this list here, we know that we're essentially telling the large language model, hey, fill in as many properties as you like as it is relevant to the age, name, and house that was selected for this character. And what's really cool here is as you start to add things such as um, doc strings or other deeper descriptions. So like in here, you can write in description must be snake case. All of this information is passed to the large language model so that all of these restrictions that we place in are followed by the large language model. And if any failures occur, instructor re-hits the model and runs validation to ensure that at any point it matches this. So let's say Hufflepuff was, it didn't say Hufflepuff, it said it made up a new house. Behind the scenes, what would happen is that instructor raises that error and says, no, let's try again. Let's actually ensure that this is the literal answer that you're providing. And so this is also done, while this is all done implicitly, so like validating whether or not something is snake case based on description, we also use validators directly from Pydantic to do this ourselves. So for instance, one thing we wanted to do is have a validator that does check if a citation exists. So what it does is we go to the context and grab the context itself. And if the context gets and we know that the context is the text chunk itself. So if the context in general doesn't have this citation V value that we want, then we know that there is a problem that is occurring. And so what happens is that this error we raised behind the scenes when you use it with a large language model, this is just my long-winded way of saying is any additional validation rules you want to put to your Pydantic object are propagated to your large language model. So if at any point error is raised, we know to retry the large language model itself, or we can also build in stronger error handling based on what type of specific error was raised by our large language model, which may have failed in the generation of this specific schema or structured output we want. This is all to say that we also use instructor in that data labeling and clustering use case that we're talking about now. So if I were to jump into, I do apologize. I did not mean to close this. That's fine. If I were to go ahead and jump into the notebook itself, we can see here that, so we use the GPT-4 Azure model in this specific situation. What we do is we actually have this clean list of companies where we have a description about the company name, the category, and some other things such as the year was founded and then the raise amount. So we can just rawly go ahead and cluster this information. So based on the first level of clustering we do, so let me go jump into do apologize. GitHub.com. This is why I love live stuff. 1b/LM workshop. Part 2 structured output. And cluster text is coming from clustering utils over here. All right, so we can see here that we first just run the initial clustering. So we use mini LM L12, UMAP, and HDB scan to go ahead and run the initial clustering that we see here, and then render it in bokeh. And so we can see that this cluster is doing an okay job. This is actually not like actually I would say it didn't do that great okay job. There's like a couple of clusters out here, or there's like green cluster out here that's all similar in the corner, but overall I think it's very noisy. Um, but if we actually go ahead and do it with BERT topic, we can see here that there is a little bit better clustering. A lot of blues are nested in this area in the corner here. Reds are strewn throughout the middle area. This nice little section over here in green is nicely clustered together, or lime green. And while this lighter green or this darker green is all clustered, um, this blue does a really good job of clustering out in the bottom right, this cyan. But in general, I think we can do a better job, especially as we can look in here and see that it just says -1, 4, 9. Even though we have these clusters, we don't have names for them. So what we instead do is now do that multi-level workflow we mentioned, where we we name the cluster, we deduplicate it across the different clusters that are assigned. So sorry, we name the cluster, we assign each of the companies to each of the clusters, and then we go ahead and deduplicate based on whether or not some of these clusters are too related together. All of this is done via a large language model. So if I were to go ahead and write name clusters, so we go in here, we can see here that we actually run this with our cluster response model. If I go to our cluster response model, we can see that we have the name of the cluster we want. We also have this chain of thought, which comes from our previous section. We actually understand the thought process that came into why we named a certain cluster the way we did. So if I actually go ahead and jump into our dashboard here, let's go to name clusters, go to the outputs over here. We can first see how many times you actually ran ahead and did this naming cluster workflow. Very expensive, I would say. So be careful running this notebook if you guys are interested, because we are going through each cluster, naming that cluster, aggregating them all together, and then deduping, assigning, deduping, assigning. It gets very expensive as we're doing this over a large quantity of data. But if I were to full screen all of our clusters, we can see we actually threw in our raw data frame into here. Does it look better in Markdown? It does not look better in Markdown. We'll do it in maybe code. That's fine. But we throw in, for instance, this data frame directly to our large language model. And then output, we can see that here are all the list of clusters that exist. Problem here is that there are 61 different clusters, many of which are actually can be considered a bit redundant or actually just ambiguous, like advanced technology solutions, like or advanced technology solutions. How does that differentiate from enterprise tech solutions or text-driven business solutions? So like all of these solutions, for instance, may not actually have the clearest name. Oh, nice when things break behind the scenes. It's fine. So similarly for assigned clusters, we actually go ahead and then take that opportunity to understand, given the data frame of data and the cluster names that exist, where should each company be clustered to? So we can see here that we now have the category alongside the company name here. Sorry, not category. There is the data frame. It's not rendering as nicely. That's fine. Yeah, so we can see, yeah, for each company, what clusters we've assigned it to, for instance. So if I were to go to one specific instance where I have this specific description, so about Cohesity, we have all the available clusters that have cluster names available to us. We can now see that we actually select the one cluster we want to name Cohesity, for instance, so advanced data storage and management, and the reason we want to do that. So Cohesity develops an intelligent data platform that converges secondary storage workflows, etc. So in this case, we can now assign Cohesity to this new cluster and do that for every company. Afterwards, though, we may not be satisfied with that output. So you want to actually go ahead and deduplicate some of the cluster names. So given all of the clusters that exist, so all 313, for instance, what we want to do is run a function where we actually go ahead and deduplicate our cluster. So over here, we actually use this unique clusters class. So list of deduplicated and cleaned up cluster names, where the prompt for that cluster, that clustering technique. So we use this cluster cleanup prompt. You're an expert analyst and super intelligent clustering assistant. You look at groups of companies or product descriptions and identify clusters. This results in a set of cluster names that contain some overlap and duplicates. Your goal is deduplicate and clean the clusters. At the same time, keep the clusters specific, meaningful, and granular. Here are some examples. Here's what the example looks like after cleanup. And here are examples that are too generic. So you can see here how we use some of that understanding from the previous prompting paradigms that I mentioned earlier, and use that within determining a really good prompt for deduplicating our clustering data. So after running this a few times over and being able to see the actual decomposition in our Weave dashboard, where you actually only look at the name, but can understand for each company what decisions were made, or for instance, for a specific deduplication, understand, sorry, it's in here. Dedupe cluster names, full screen. Outputs is here. Where's the breakdown of it? Okay, so in this specific situation, we don't have the chain of thought explicitly in here. That is fine. It's in the sign clusters. That's totally fine. That is to say, though, after running a couple iterations of this, we're actually able to get really well-named clusters for the different companies that we're embedding right now. So like in this case, for instance, maybe this specific one, this collection of yellow ones in the corner over here, you can see that these are all biotech innovations with AI and cloud technologies. So things such as In Citro, Schrodinger, Immune AI, and Nimbus Therapeutics all fall in this category. Similarly, if we actually look at things such as the another closely related clusters, we have health tech and genetic diagnostics, also next to digital health platforms. You can see all the health stuff is all located really closely near each other. But if I were to go to a different area, let's see one that looks a little bit nice. Some of these are really... Here's a little orange one here. We see these are graph database solutions, which are nested closely to advanced data storage and management, API management development solutions. Don't know if that's the closest one. Or data visualization toolings, which can also fall into some of these graph-based solutions. So we see here that we actually use LLMs alongside standard clustering techniques to iteratively refine really strong cluster names, and then also be able to decompose and understand how those decisions were made by our large language model to come to those clusters, and then see the effects in a more experiment-based form, where we can also understand things such as the effect of changing up these prompts on the outputs of our clusters, for instance. And also, once given all this information, we actually go ahead and make even deeper charts for our data visualization fans. So for instance, we can see here that in 2019, there's a pretty much only one MLOps platform, and then they start to grow up until 2019, in which Weights and Biases was finally released. And then we can see that from there, because there's no other better solution around, there is now a lesser amount of MLOps platforms being made in the world. Jokes aside, using LLMs alongside standard data analysis techniques can cause really good understanding of your data itself by ensuring that instead of using gut checks for certain techniques itself, or using more statistical approaches that may not have the highest quality of responses, so using things such as like the TF-IDF, techniques like a large language model can help supplement your analysis itself. And using experimentation platforms like weights and biases, Weave, alongside secure platform tooling and latest and greatest AI solutions provided by Microsoft via Azure OpenAI, or even things such as, this was not shown earlier, but even things such as the AI Studio, which are all very um, easy to use and set up, all can all work together to really enable you to create really strong business workflows. Be that data cleaning, um, use case extraction for your prospective customers, or like in this case, clustering large industries to understand what trends may exist and who maybe your certain features should be marketed to. Um, oops. And so, in general, we learned that these kind of really strong data workflows on top of LLMs do work really effectively. I highly recommend using Instructor alongside the prompt techniques I showed you earlier to create really powerful LLM applications. But there's a caveat of this workflow will be expensive as it will require multiple LLM calls at different stages of refinement. Long outputs are very hard to manage. So it makes a lot of sense to actually split up LLM outputs into like in the chain of thought kind of way, or the chain of whatever kind of ways. The structural enhancement techniques I mentioned earlier, it makes a lot of sense to decompose your complex problem into more manageable steps, as it's easy to not only work with, but also to validate where failures occur in your LLM usage. And validation helps, but can also cause problems. So even if you run Pydantic classes with model validators, it's not the best in the world always. So that's why it's also really useful to do things such as evaluation, which is the hardest thing that is currently existing in the large language model form. But hopefully I'll be able to give a talk later soon to give more insight about how to evaluate properly. And so a little glimpse into that is that one thing that we can offer, that Weave helps you with, is that given a published evaluation data set, you can utilize any evaluation data set alongside the Weave evaluation scorer to build in nice dashboards, which allow you to understand and drill down which version of your LM application. So like in this case, I may have an Azure email assistant alongside customer service and queries, and understand what the internal machinations of that specific LLM model looks like. So in this case, what my prompt and prompt template look like, alongside how it responds to all the data available in my data set itself. So I can understand, hey, is my model doing the best it can do? So if I go to this, go to evaluate, you actually see the outputs of your model and things such as scores like conciseness. So I would like to say uh, thank you all for joining. I do understand it was a bit long and a bit verbose, but hopefully there were some useful pieces that you can take from this talk that is useful for your business. So hopefully you'll all be using LLMs for your data analysis use cases soon with really strong prompts and hopefully a little bit of instructor. Thank you. And if you have any questions, I'd love for you to ask them now. And hopefully see you at Build soon. So I will be going to the question screen right now. Cool. Um, I'll walk through a couple of them. So is ChatGPT an LLM or generative AI? It is both. So ChatGPT is LLMs are generative by nature, because what they are doing is they are generating new text given internal understanding of the data that it was trained on. So generative AI compass is the bigger bucket, which encompasses text to audio, text to video, text to image, and etc. In this case, this is text to text. So yes, large language models in this case are a version of a generative AI. So next question is, which prompt technique is the most effective at getting the best answer from the LLM? And so in this case, the sad answer is there is no best prompting technique. I will say that there are good heuristics to try out, which I was trying to show you earlier. So I would say having that very experiment driven workflow around prompting is the more important part. So I would use my heuristic, I would say, is ensure that you do the things I mentioned in the prompt engineering portion, where you go ahead and build a good system prompt that actually works with your task. Ensure that you use a templatized form of your prompt itself by ensuring that you have the context that makes sense for that question being as part of that. And then ensuring that you also utilize techniques such as chain of thought during the experimentation phase to understand the thought process of your large language model. But in terms of what's the most effective at getting good answers currently, I would say still we're at a world where RAG is really good. So where you use things such as databases hooked up with a large language model to retrieve the best context to be utilized by large language model to solve the answer being asked. But this still requires really good prompts behind the scenes. Another question is, how can I fine tune LM for a specific type of text? How many examples would I need? And how can I evaluate the fine tune model? Do I need annotations? Fantastic question. I hope I could have talk about this soon. And I'll be sharing an article soon about how to fine tune a fee 3 on synthetic data. But in general, um, if you want to ask how to fine tune, there are a lot of great model providers in the world. So a lot of good Hugging Face, for instance, is a great model provider, especially but teams such as Unsloth, for instance, have quantized models. There's also really interesting frameworks such as PyTorch, TorchTune, Axolotl, etc. All of those are things I recommend looking up. Those are all frameworks for fine tuning LLMs, usually also serving the latest and greatest, be it Phi 3 or Llama 3 or Mistral, for instance. And they also can use Microsoft tooling for some of this too. In terms of how many examples would I need, I find that question a bit difficult to answer. People have used the heuristic of like 50 to 100 is all you really need. If you are doing so from the case of low rank adaptation or parameter efficient fine tuning. These techniques are all about fine tuning large language models on a lot less compute. Because transparently, if you wanted to further pre-train or directly fine tune, those two, I would recommend looking up those phrases. Those large language models, you would need a large cluster of like A100s or H100s, depending on your model, while parameter efficient fine tuning is about utilizing a smaller volume of compute to still get that degree of fine tuning at a risk of accuracy. And so afterwards, if you did want to evaluate your fine tuned model, you can do so by doing quantitative and qualitative analysis. Qualitative analysis and quantitative analysis both require annotated data, I would say. So it is very important to say, here are like the 10 best, or even more, I would say, but here are the 10 best examples of my task I'm fine tuning my model on. Once I'm done fine tuning or during the process of fine tuning, I'm going to check how good my output is by either looking at a quantifiable measure such as F1 scores, if you want to do things such as summarization, or you may actually want to go ahead and look with your own eyes. Hey, this model output looks really bad as I'm fine tuning. Another question is, I know how weird and inaccurate Google Translate is. Can LMs fix this issue? The answer is I would be surprised if they weren't trying LLMs behind the scenes. Internally, we've actually used large language models with translation use cases. The problem here is that this requires a lot of good data still at the end of the day, where transparently large language models are very English friendly because a majority of the data coming in is English forward. So there's a lot of great work being done by the community to create large language models specifically for either multilingual use cases, where this would help with for sure, or creating large language models that are just for English plus that's very specialized language. But yes, LLMs can help fix this issue for sure. I'll answer two last questions. I heard it's difficult to make an LLM not do something. Would you have any tips? So this one is really hard because positive reinforcement is how most large language models work. is actually a very popular heuristic to never use the word not within a prompt, because not is less useful than you have to. Because not says, out of the a million possibilities that exist, I'm only removing one of them for you. And even how I remove that is ambiguous. Like, don't answer a certain way does not necessarily mean don't answer in other similar ways. However, if there is a specific question where you want to say something like, hey, I want you to do something and you can only do this, now you're forcing the large language model to only respond in that specific way and any other similar ways. So I would say it's actually better to, instead of being restrictive, which still has a large space for a large language model to mess up, I would say just be specific about your task. And so that would be more so about, hey, do you only do these things, and keep adding in restrictions on that, like do X, Y, and Z. And if they does something that you don't want it to do, be even more restrictive about what you want it to do, not to do. Sorry if that's a bit a lot of double negatives in there, but hopefully that still made sense. And last question is, where do you see LLMs in the next few years? Oh, I love this question. I would say like this is like a fun one to have a dinner conversation for all the nerds that you may interact with yourself, me being one. Um, Definitely agentic use cases are like the hot topic right now. I would say right now a big thing most people are trying to build are how can we actually utilize large language models as like an internal reasoning OS. So how can we use similar to like all the cool tools, like unfortunately like the human AI pin or like the rabbit R1 by the teenage engineering folks in Perplexity. I would say creating tools where we can just use large language models as almost like personal assistants is definitely one of the main use cases I think that will develop over the years, especially because of how compelling it is, especially in our sci-fi driven world. Um, so having automatic data analyzers or having automatic personal assistants are definitely things I think will happen in the near future in really effective ways. Because right now I think it's still not the best. And then also multimodal, so multimodal form of this too. So centralizing all the different tools together to have either one model or a very powerful mixture of models that where one is good at vision, where one is good at text, one good at text to audio, having all of them work together in a um, very performant way and a um, very latent way. So in a way that has really slow, really fast latency. I think that's also a big thing for large language models in the future. In fact, I would actually say like large language models may not even be a phrase we use in the future. It might be LLMs, which I hear being thrown around a lot, which are like large multimodal models or large action models, for instance. So language may not only be the smaller piece as we build on top of large language models. So hopefully that answered the question. Yeah, and I think that's it for me right now. Thank you all for joining. Hopefully you were able to learn something interesting, and hopefully I'll be able to see you at Build soon. Have a nice one, everyone.
Anish, thank you so much. That was an awesome session. And thank you, everybody, for joining us. If you have any feedback, we would love to hear what you have to say. You can find the link on the screen or in the chat. Please take note of that event code. Today's session, our event code is 22386. Thanks, everyone. We'll see you next time.